Today is January 27th, 2023. This is my 206th episode for C++ 17 2023 CUDA Spherical OpenGL OpenCL TBB Vulkan. This is 36th episode for vector calculus. Second episode for multivariable integrals, triple integrals in spherical coordinate systems. Without further ado, let's get started. Open up Visual Studio Code. Select empty space. Click this button. 206 Spherical. Click this button. sph.cpp. Hit enter. Control B. Include CPG, SED extensions. Include CPG, calculus. Include CPG, chrono random. Namespace, CNA, CPG, numerical analysis. Namespace, CPT, CPG, types. Namespace, CCR, CPG, chrono random. Using namespace, CPG, numerical analysis. Commands. Using namespace, CPG, operators, and constants. I would copy these links. I will put line break here. Control Home. Before we start this session, I will make clear two things. From spherical coordinate system, please control-click this link. In the spherical coordinate system from Wikipedia, scroll down. Spherical coordinates are theta, phi as commonly used in physics. This is standard convention used in physics. R is radial distance. Theta is angle measured from the axis of Z. This angle theta is called polar angle. This symbol phi is measured from the x-axis in the counterclockwise on xy plane. This angle is called azimuthal angle. I pronounce this Greek letter phi, not phi. I pronounce this Greek symbol phi. Please remember the names. The angle represented by phi is called azimuthal angle. Angle theta measured from the z-axis is called polar angle. This polar angle increases from the z-axis downward like this. This theta increases downward from 0 to phi. Now scroll down. In mathematics, spherical coordinates are represented r radial distance from the origin to a point in space. This phi measured from the z-axis increases downward up to pi. This angle phi is called polar angle. This theta represents angle measured from the x-axis in the counterclockwise on xy plane. This angle theta is called azimuthal angle. So, the symbols used in physics and the symbols used in mathematics is swapped. You should be very careful about this. If you remember, angle from the z-axis is called polar angle. The angle from the x-axis is called azimuthal angle. You won't get confused. But if you remember the symbols themselves, you would get very confused when you apply your mathematics to the problems of physics. Keep this point in mind. The symbol theta and phi used in physics is swapped with those symbols in mathematics. Okay, they are swapped. So you have to memorize the names, the meanings of symbol. Instead of theta, try to remember as azimuthal symbol, azimuthal angle. Phi should be memorized as a polar angle. In the same manner, this phi represents azimuthal angle. This theta represents polar angle. If you memorize the names, you can never get confused. However, if you try to memorize the symbols, you will get very confused in future. I need to mention one thing more from Greek alphabets. Control-click this link. In this table, if you scroll down, you can find this symbol. Copy, paste it here. It changes. Anyway, this symbol is pronounced phi. The Greek pronounced this symbol phi. In this table once again, this Greek letter is pronounced p or p. This symbol is pronounced phi. This symbol is pronounced p or p. In English, they pronounce it like phi. I will pronounce this symbol as pi, but I will pronounce this symbol phi, not pi. Now, from Thomas's Calculus, 13th edition, page 928, figure 1542, copy this page number. From Thomas's Calculus, page 928, you can find figure 1552. In spherical coordinates, we use the volume of a spherical widget, which closely approximates that of a cube. So, I view this widget as a cube. Here, horizontal, this side is horizontal. Vertical is this side. Depth is this side. Horizontal times vertical times depth times gives this volume. This volume is this. Once again, this side is horizontal, this side is vertical, this side is depth. If you multiply them all, you will have this volume. Now, scroll down. I assume you read this text. For example, sketch. The region D along with its projection R on XY plane. The region D, this is the region D along with its projection R. Label the surface that bound D. This surface is labeled. Then find the row limits of integration. So this is row limits, lower bound, upper bound. I assume you read this text very carefully. I will not read it for you. Example 5. Find the volume of the ice cream cone D. In this figure, this volume looks like an ice cream cone. D cut from the solid sphere. It was solid sphere cut rho less than 1 by the cone phi pi over 3. This is cone. Now I will arrange. This is page 929, example 5. Void test, spherical volume, example 5. Int main, copy the function name, paste it in function main. Here we are finding the volume of this ice cream cone. Or integrand, we create a function rho phi theta. Please understand, we have to maintain the order of these parameters, ordered triplet. In this case, rho phi theta or radial distance. This angle is called polar angle. This angle is called azimuthal angle. You should remember the order of these parameters because it is ordered triplet. Now, semicolon. Return the volume is represented rho times SCD. If you do not remember, reference this. So rho square sine phi. It represents volume. Rho v CNA integral. We have to pass LCD, make tuple, copy, paste. Now watch very carefully. In this figure, the azimuthal angle theta sweeps from 0 to pi. So 0.0 to pi. This is theta limits. Now we need to specify dt for theta. Then this phi runs with respect to z-axis. This point is 0. It runs downward up to pi over 3. So 0.0 pi over 3. This is phi limits d phi. Then this m is a line from the origin in the direction radius or radial direction. This line m runs from origin 0 up to on a point on this sphere. The radius of sphere is 1. So from 0.0, 1.0 rho limits, it should be d rho. This is our integration. Of course, we have to pass integrand. SDD, C out, V is the volume, V, I will give carriage return. The answer is, I will make it smaller. The volume is pi over 3. Pi over 3 is the volume, CPG and L. Now open up any compiler. dir cd 206 spherical. I will use GNU compiler, std c++20 sph.cpp ltbb12 og.exe, hit enter. clsg, our numerical computation matches with the answer. I will change like this. I had some sleep. I will resume filming. Open up Visual Studio Code. We implemented example 5 in page 929. Just so you know, I will drag Thomas's Calculus 13th edition here. I will make it big. Ignore. Then here VS Code PDF, display PDF file in VS Code. Install. Okay. I will close it and open again. Okay. Here in example 6, page 929, a solid of constant density delta 1 occupies the region in example 5. Find the solid's moment of inertia about z-axis. So, to compute moment of inertia, we have to multiply distance squared, okay, on xy plane, distance squared on xy plane, or rho square sine square phi. Our density is given 1. I will make it smaller. Example 5. Scroll down, copy, paste. This is page 929, example 6. Test spherical moment of inertia. Example 6. Our density, or density, is defined 1.0. Okay, if our density is not constant, then we can always define as lambda, or rho, or phi, or theta. We will simply return 1.0. Now we need to integrate mass. So it should be integrand mass. We capture density. Then I say mass. From here, density times rho v theta times. This is integrand for math. Now copy, paste. Integrand for I, G. Here we have to multiply R square to our integrand. We can compute rho R like this. Rho times SED sine phi. You have to remember this. In spherical coordinate system, points distanced are from the origin on xy plane is, I will copy the symbol rho times sine, I would copy the symbol phi. That is R equals rho sine phi, where rho is radial distance to the point, phi is polar angle. You have to be familiar the name polar angle. Also, what radial distance mean. R represent points on xy plane in spherical coordinates. You have to be very familiar this concept, or it can be represented square root x times x plus y times y. So R square equals x times x plus y times y. So we have to multiply R square. You should never forget this. Now here, this is math M. Copy this integrand, paste it here, copy once. We say I, G. We pass this integrand here. Now math M, copy, paste. IZ, our answer is, if you scroll down, pi over 12. So pi over 12. Now open up command prompt. Sorry, I have to copy this function. Copy, paste it here, disable it. CD 206 spherical clang plus SCD C++20 sph.cpp ltbb 12 or c.exe, hit enter. CLS C. So our numerical computation and the algebraic answer matches exactly. If you want to, I will specify SED cout precision 14 decimal places. If we build again, CLSC, our calculation is extremely accurate. See, we are solving such scary computation. It is a serious computation, but our numerical solution is extremely accurate up to 14 decimal place.